gate.
What we're going to cover today is how to derive a Boolean expression from the logic circuit, which you've already covered. In the first case, where we have a 2-input AND gate, we're going to feed that into a 2-input OR gate like this. Now the first part of this circuit, its actual Boolean expression, as you came across earlier, is A and B. So we're going to write this down here, A and B. Here's our output. So that the first thing that we're going to identify is we have a 2-input AND gate. The second part of this particular expression that we're building is going to actually have an OR gate in there, so we're going to use the 2-input OR gate. So we're going to represent that like this. Notice that I've already got the OR symbol in here, which means that this is occupying one of the inputs to the OR gate. This next part right here is another control signal, and we'll call that C. So by the time we're done writing this expression, we actually got a C that we add onto our expression, which now tells us exactly what we've got. Actually, I could go from here to the circuit, or I can go from the circuit to the Boolean expression. In the first part, and you notice that we have little parentheses around it because it's its own circuit. It is A and B, and we're going to OR that with C, the C variable out here. So all we have to do is just add it. So if we're looking at from the expression back to the circuit, we're going to go from A and B, which is right here. We're going to OR that with the C, and it's right here on this particular device. Let's say we want to add a little bit more onto this. Let's say that instead of having a logic high output, we're going to have an inverted output. And as you noticed in one of the previous videos, the bubble out here means that the output has been inverted. It's the same as a NOT gate. So if I wanted a NOT gate, all of this out here would be the same as having the same circuit and putting a NOT gate, but conveniently we can put this right here, and if you recognize the symbol, we've actually got a 2-input NOR gate. It's right here. But notice as we progress from left to right, we have to take into account as we're writing it just exactly what we're looking at. So in the case of this one out here, what we'd actually be looking at is something that looks like this. This part right here is its own entirety. It's a 2-input AND operation. And it's going to be NORed with C right here. Now if you look right above the logic operator, I've got one line. What that indicates is what the very output of this is right here. So we can take this output and put it right down here so that we see what the operation is. We have OR, NOT, OR, NOR. And we have one input here. The second input is right here. And that's this whole line. Comes in from some control signal that we simply labeled C. So now as we're looking at this whole circuit, we have the 2-input AND gate. We have the 2-input NOR gate. But the thing is if we look at the output of this one particular signal right here, we're going to notice that it is right exactly here. It's identified by the logic operator and by the complement bar which sits right above it. So if you need to distinguish where the AND gate is, make sure that the parenthesis is in the 2-input variables right here, set all by themselves. A and B NORed with input C. One other thing we can do, let's say that we want to change the AND gate to a NAND gate. As you might have guessed, all we have to do is remove this part right here, change the output of the AND gate from a conventional logic high output, put a bubble on its output, same as a NAND gate, and we have this part labeled right there. Now we're looking at a 2-input NAND gate, which is this part. We're now going to still NOR this with variable C. It looks exactly like this. NAND gate, NOR gate, and everything is accounted for on the inputs A, B, and C. They all derive all the way out to just one output Y. That's exactly how you would write this. Here's the logic gate expression for this particular circuit. One other thing you could do if you wanted to, let's say you want to NOT the input to that C. All I have to do is put that NOT gate right in here and declare it right there. Now I've actually got the 2 input and NAND gate, and it's going to be NORed with a 2 input NOR gate that I've inverted the variable C. That's really all we have to do. I'm going to go through some other examples, but this is just a very basic example of deriving a Boolean expression from a logic gate circuit.